Today we're going to take a look at the quick sort challenge from Topcoder. A quick sort is basically a sorting method that takes an array, chooses a pivot point in the array, and that point can be pretty much anywhere in the array. And that pivot point is typically a value that's going to be compared against in the array. And once that pivot point is selected, then all values that are less than that pivot point will be shifted to the left of the array, and all the values to the greater than the pivot point will be shifted to the right. And then what happens then is that shifting to the left and right build partitions, and those partitions are then recursively sorted using that same quick sort algorithm. So again, the left array, the left subarray will choose a pivot point and then be sorted around that pivot point, and so on and so forth until there are no more items in each subarray, and then it's recursively built back up on each side. Okay, so let's go ahead and take a look at the quick sort that I've built. Again, the basic description of a quick sort is up here in the comments. Then the method itself is rather simple. So again, it's just choosing a pivot point, creating left and right partitions that are either less than or greater than that pivot point, and then recursively doing the same thing over and over again until it builds the array. Okay, so the quick sort takes in an array, and it returns an empty array if the array is in fact empty. Once the empty array is returned, then that returned array, or that returned complete splat array, will then be sorted on whichever side of the pivot point. The pivot then is going to be chosen, and I use the delete at built-in method for arrays, and it's chosen at a random item in the array size. Okay, so again, not knowing how large an array is or how many items are in the array doesn't really affect the viability of this quicksort method, because it's not searching for a specific value, it's just searching for a location in the array, and then whatever that value is, it pulls that value out and then shuffles the array around it, or sorts the array around it. Okay, and then I'm going to use Ruby's built-in partition method for arrays, and again, a partition is going to create two subarrays. As you can see, I'm making this the left and right values, and those are the left and right values of the pivot. And it's going to partition the arrays by taking a look at each number in the main array, and then if this condition is true, it goes into the left array, and if it's false, it goes into the right array. So it's going to choose any number where the pivot is greater than the number, and it's going to put that in the left array. And where that's not true, or where pivot is less than the number, it's going to throw those numbers in the right array. This comment here I'm actually going to remove once I turn in, but this comment will actually show us those subarrays as they're built. And then at the end, once it's done all of that, it is going to return a value, which again, this is the recursive part of it, and this is a splat operator, so it will recursively sort the left side of the arrays until that splat operator's completely been used up. And then once it does that, it's going to place those values into the array before the pivot, the sorted values into the array before the pivot, and then it's going to do the same thing with the right hand side. And again, it will recursively do that whole left and right pivot idea. Okay, so let's go ahead and we'll run the test, the actual RSpec, just to show you that it works first. All right, and again, I'm just using the basic RSpec command. You could, in fact, use the very specific RSpec command, quick sort B, and as you can see, it runs all of the. Oh, that's strange. It didn't run any of the examples. Because there are no. I forgot the spec part. There we go. Okay, so I did change the rspec command a little bit. I made it so that it shows the documentation as well, instead of just dots, so we can actually see what happens here. Okay, so for each of the quicksort tests, it moves the largest integer to the end of the array, that's to the far right, moves the smallest integer to the front of the array, that's the far left, handles an empty array, again if it's empty it returns empty, handles an array of length 1, again if there's one item in the array it will quicksort that array, but it's choosing that as the pivot. So when it returns the values here, it's just returning the pivot, because when you concatenate an empty array with a value and another empty array, you get the value only in the array. It sorts array from least to greatest, so it passes that test, and it handles 0 appropriately, which basically just means that if there's 0 in there, it's testing whether or not 0 is greater than or less than the pivot point, and if it is or isn't, then it puts it in the appropriate location in the sort, and it handles negative numbers appropriately. Okay, so too easy. So let's go ahead and run these tests, and we will run them without showing, let's show the array, the subarrays. So I'm uncommenting my test that we can see in the file. Let me clear the screen again, and then actually run the file itself, and see what it shows us. Okay, so the array passed in, again that's the array here, and I just ran the shuffle method on it to shuffle these 6 values. So 3, 2, 1, 6, 5, 4 became the array that I'm going to end up sorting. Okay, then it chooses a pivot, and the pivot value that it chooses for the first pass is 2. So if I go through this array and take a look at all the values, the only value less than 2 is 1, so it puts it in the left array. Then the values greater than 2, 3, 6, 5, and 4. Notice it doesn't sort the array here just yet. It just places them into that partition. So they're placed into the right partition. Then the left side, again because the left value is first, the left side is then quicksorted again. There's no value less than 1 because 1 is the only value in the array, which again proves the handling one value point. There's no value into the right array, so that array is now sorted, and that will place that value into this splat here before the pivot. And at this time it probably also places the pivot because there's nothing else in there. Then it will do the right hand side, the right hand splat, so it takes a random value in that splat, and here it chooses 4 as the random value. Notice 4 is over here on the end, so it doesn't really matter where it is. And then it sorts all the values to the left of 4 into the left hand array, or less than 4 to the left hand array, greater than 4 to the right hand array, again unsorted as of yet. Then does the left hand side, which is 3, there's only one value, so again just like we saw with the 1, sorts it and places it up here, and then it sorts the right hand array. So 4 has been placed as well. Then it chooses a new pivot, which is 6, which is the first value in the subarray. There's a value to the left, which is 5, and no values to the right. So then it's going to actually sort the left-hand side. Again, it sorts the left hand first because that's how the quicksort works. And once there are no values to the left or to the right, and then it just places those values into the remainder of the splat sorted arrays. And so our sorted array then is 1, 2, 3, 4, 5, 6. Okay, and that pretty much covers it. Now we can test to make sure that all sorts of values work. Let me actually borrow something real fast from a previous sort method. Right, and this is just to show you that it works. Okay, so what's going to happen here is I'm just going to take random values from, or 10 random values from negative 100 to positive 100. So again, these are negative values, could be 0, could be anything between those two values, and it should sort it in the same sort of way. All right, so let's actually clear the screen, run it one more time. And as you can see, it builds those subarrays, and then it builds the sorted array just as we saw before. So again, quicksort is really fast. It's an in-place sorting method. It finds pivot point, creates partitions, sorts those partitions around it using that recursive quicksort, and then rebuilds the final array in sorted order from least to greatest. Another great thing about quicksort is the simplicity of the method here. If I wanted to sort it from greater than to less than, I would just change my value just like that for the pivot test, and then it would just flip those values around and sort it from greatest to least. All right. Again, just like before, if there are any other questions, please feel free to ask them in the forum, and that'll be it. Thank you.